Thank you, Krista. Good morning, everybody. I hope you had a nice night after this nice dinner. First, I would like to introduce Clotilde Patry, just here. Clotilde is French, but also international. She works for ELIANCE, which is an umbrella organization in charge of insemination and performance recording in France. But she's also deeply involved in Valogen, who is a company who markets genomic breeding values in France, but also buys Illumina chip for the European community. And she works also for Eurogenomics, which is a European alliance of the breeding company in Holstein. And I think she's the right person to... She made a PhD in our lab. She also spent quite a lot of time in India also in order to try to develop genomic selection at the early age of genomic selection in India. So, you to play now.
Thank you very much, Didier. So good morning, everybody. Didier already introduced a little bit what I did so far, and I think I already got a lot of chance to have different experiences with genomic selection in different countries, but always in cattle. And I think this morning, and also yesterday, it was also a chance for me to participate and to attend the BovReg final conference. So thank you very much for inviting me to this event, because coming, in fact, yes, from the industry or working closely with the industry, it's always very interesting to take time and to have this opportunity to learn more from you from the research side. So first, thank you, and thank you for inviting me. Thank you, Krista. So the question that was raised to me was how to connect, in fact, and how to recognize the value of the research that you are doing through BovReg or through Eurofond, for example, and what is the value that is provided then to the industry. So I will try to connect a little bit, but in fact, so my presentation will be very broad, I would say. So how we transform this knowledge into services to the farmers, and I will try also to highlight the very important link, or the importance of the link that we have to do in between the research and the industry. And I think our French organization and also the European organization through Eurogenomics can provide some example about that. So, is there any? I don't know how to use that. Yeah. So just a few words about ELIANCE, because I'm working for ELIANCE. ELIANCE, in fact, this is an umbrella organization that has members, in fact, across the French territory, but also one member, Laoui, that is based in Belgium. And amongst these members, we have people that are very dedicated to genetic improvement, so the AI companies, but we have also, and we should not forget, all the milk recording organization or the beef recording organization that collect the data and that allow us to transform data into advice through, of course, all the research that is done in between. And maybe just one figure about ELIANCE. So, of course, so we try to cover cattle, goat, sheep by providing either breeding values and more generally advice. But at the end, it's 80,000 farmers that can benefit from this kind of services. On the field, it's about 100 companies that deliver routinely this or daily this kind of services to the farmers. And if I want to talk a little bit more about ELIANCE, in fact, ELIANCE, it's about 60 people, but about 40 people are involved into research. And they could be introduced or included in some research team like INRAE, Industrie en Josas, and especially in the field of genomics or epigenetics. And ELIANCE is also a member of IFAB. IFAB is the European Forum for Farm Animal Breeders, and ELIANCE is contributing to IFAB for cattle, goat, and sheep. And we are also very thankful to IFAB because they allow us to connect in between research, policymakers, and the industry. And it's also very nice to have this view across the different spaces. So now I will start from I would say, our daily life and the fact that now genomic selection is a routine. It's a routine because we are genotyping, so every year now more than 1 million of cattle. The figures that I'm showing to you, these are the figures that we can gather at the Eurogenomics level. So it means that this is the genotyping activity for cattle for France, Germany, the Netherlands, Belgium, Denmark, Finland, Sweden, Poland, and Spain. I hope I did not forget any countries. But so it's, now it's more than 1 million of cattle that are genotyped with the same tool, which is the EuroGMD bed chip. In total, so since we have the customized bed chip, it's more than 7 million of cattle that has been genotyped. And the idea is to be able to, of course, to genotype, but to provide services for any kind of breeds. It could be dairy breed or beef breeds. It's a very generic tools for all these different kind of breeds. And what is behind, it's always the fact that we want reliable prediction. And this reliable prediction, they not only come from the quantity of data that we have, but it also comes from the knowledge that is behind and how reliable and how relevant the knowledge is for the needs of the field. And in fact, so these results, so the fact that we are genotyping a lot of cattle, it's on one side, it helps us, of course, to provide genomic prediction. So this is one of the services that, of course, we are delivering. Of course, it can also be used for pedigree verification, for monogenic traits to be detected. It also helps to manage variability, genetic diversity across the different population. So these are the routine services that we can deliver. But in fact, behind these chips, this is even more because the chip is including not only the validated variants that, for example, you discovered, but it also including the variants that you just discovered, for example, through the different process, sequencing and GWAS and so on. And in fact, they are introduced into the chip to accumulate a certain number of data in order to validate or to contribute to the validation of the variants. So this tool, it's not only a tool for just a routine, it's also a research tool that is shared across the different countries or group of researchers that I described a bit earlier. So for me, and I'm working with this kind of tool and with this community since now a certain number of years, and I think it's a very impressive way of working together and a way of linking research and industry. Industry is maybe providing the quantity of data, but research is providing the quality side of the data. And one of the output of this is to have very relevant information that are useful for the farmers. And among this relevant information, we have all the causal mutations that have been discovered across years and that are very, of course, very precise, not only at the breed level, but across breeds. And right now in France, and I will take the example of the French genetic organization, we deliver every week, we deliver results for more than 340 monogenic traits in 29 breeds, so dairy and beef breeds. So sometimes we are talking about the same genetic disease or the same positive characteristics, but at the end, that's a lot of results that are delivered every week and with a high level of reliability. And this helps to manage matings and to manage disease without, of course, dilating too much into the diversity. But so I'm talking about monogenic traits, but what is mostly used, of course, these are the very complex traits, or at least the polygenic traits. And I would say that a few years before, we were delivering about 40 group of traits with genomic breeding values. And since a few years, we can see that it is increasing a lot, more and more new traits. But these new traits might be very, very complex, and we need all the knowledge coming from the research to be able to deliver more traits that are very relevant now for the farmers. And I'm just showing some example of articles where the French team, so from INRAE, has been involved, and about this disease that is called in English the Jones disease or the paratuberculosis bovine in cattle. And the idea is to increase the resistance to such kind of disease, and which is very important right now, and very recognized not only by the breeders, but also by all the sanitary organizations. So it's really a great improvement to have this knowledge in genetics that can be used not only for farmers, not only for breeding purpose, but also for sanitary reasons. But behind or beside these traits about animal health, we can also discuss about welfare, because this is also very associated, and this is also something that is that we need to work on, to improve, or to work with that topic. There is also a lot of new traits that we can find in the field of reproduction. There are also some traits about the product quality, so it's very important to recognize the quality of the product, for example, the quality of the milk, the quality of the cheese, so that the industry that is purchasing this kind of product can recognize the value of what has been done by the farmers. So it has an important economic value. What is also important economically for the farmers, it's feed efficiency. And one very important topic that is very discussed right now, it's all the environmental impacts of cattle breeding. And we know that there is already a lot of work to be done, or that has already been done with methane emission. And the fact that, for example, from some phenotypes under the middle infrared spectrum, the fact that we can start from this kind of phenotypes to predict potentially the methane emission based on, for example, milk composition. But we are still waiting for the next GBVs that should come very, very soon in France. And an important topic is also heat tolerance. So these are very up-to-date topics that you know very well, but just to know that behind, of course, this is very complex to describe the biology that explain the behavior of the animals, but step by step the industry is including it and need to include it anyway in their different strategies. So genomic selection, so this is the results of a long pathway bringing together a very reliable knowledge, and now it's a profitable commodity. So I think you are better on the science side than maybe we are on the economic side, because it's always very difficult to show the economic interest of genomic selection. But in fact, looking at different studies across the world, whatever I would say the livestock system, whatever the country, it is very often shown that there is that genotyping and genomic selection is, of course, very important economically for the farmers. But it's a long-term investment, and so the results are not shown on farm directly from the first year, but after a few years, and it's important to convince not only the farmers, but also the technicians that are providing the services, how important genomic is. We strongly believe that genomic selection, this is not the end of the pathway, so we have a lot more to discover and to learn to explain the variation across the different phenotypes. And in France, we believe, and I'm sure that it's not only in France, we believe that we need to move to epigenetics, so to add this information to the genomic breeding values that are computed right now. So right now we have our GBVs. They are quite accurate based on very reliable information, based on a large quantity of data. But we believe that based on epigenetics knowledge, and if we distinguish what can be transmitted to the next generation and what is not, we could explain even more the phenotypes of the animals depending on the environment. And I think it's very important because we are not here to define a standard cow, but we are here to provide to the farmers the clue, the keys to adapt to a changing environment. And also it's not only the environment that is changing, this is also the practices that are quite diversified now across the territories. And this is a will for the farmers to have more knowledge to adapt. So the most important is to adapt. And epigenetics is maybe a clue, and based on our network, so the ELIANCE network, which is not only breeding companies, but also companies that provide advice to the farmer, we think that we could help improving the management of the herd with this kind of new knowledge. But for that, it means we need to accumulate some knowledge, and we know that thanks to your project, previous project, but also the Rumigen one, which is a big European project that is currently ongoing. We need to go with more concrete tools. And one of the aim of the Rumigen project right now is to provide the equivalent of the genotyping chips that we are using right now, but for epigenetics. And to do that, we need to use a lot of data and knowledge that have been already accumulated. And what you can see on the graph, in fact, this is the process, how we came from very raw data, sequencing data, and so on, to a tool. So it means that at the very beginning, we got a lot of data. And for example, when we started the process with setting up the chip, the epi chip that will come soon, we started with a lot of CpG information because in that case we focused on DNA methylation, and we needed to filter across or among these more than 200,000 CpGs. And for that, we needed to use all the data that were already in the literature, or the data that came, for example, from the different projects like FANG, the annotation, and so on, so that we could really target what we could consider as a relevant information for a first use, which is still a research use. So and maybe something else that I forgot in the previous slide to mention, I know that there is different approach, in fact, to develop this kind of tool. And what we can recognize with Rumigen is the fact that this is biology-based. This is based on a better knowledge on biological mechanism. So this first EpiChip will come very, very soon because it will be released now in a few weeks. It is announced for beginning of March. So we are preparing inside the Rumigen project to test this chip. So first we will need to validate technically the chip. So if there is any, so this result in comparison with previous results on same samples. Then it will be used for research, so inside the Rumigen project. So can epigenetic improve genetic evaluation and individual predictions? So that will be one of the aims of the project. And then we can expect, or we hope, that we will see a further version that will maybe use the results of, for example, the BovRec project. So to always improve or take a better advantage of all the knowledge and annotation. And if these first steps are conclusive, then maybe it will be used for the routine. But still a lot to do. So and now I'm coming to the conclusion, because maybe I burnt all my time. Sorry for that. So we used to say that there were some challenges with cattle genomics that are very well known. So the first step is to know the genome, then to assess the potential effect on specific traits, of course, to access cost-effective tools for reliable prediction, and then, based on that, you can take informed decision. But I think that now we have even more challenge, because I have the impression that we gather a lot of information, a lot of knowledge already on the genome, but we need always more information coming from the environment and coming from the way we collect the phenotypes, so that we can be better in predicting the phenotypes. So what I can see so far is that we are maybe lacking also tools or data on environment to really make a better balance in between the knowledge that you have on genome and what we can get from environment. Because with epigenetics, we believe that it is more and more informative. It will bring more information about environment, but for that we need also some more data on environment and understanding in between genotypes and environment. So just, it doesn't work. Oops. And just to conclude, so if we go not only from genomics, but if we go to epigenetics, we will need to know, so not only know the genome, but know the impact of environment on genome, and to go further with that. And in that case, the second step will be access more accurately potential effect on specific traits. And then we have still the same question to access cost-effective tools. I already talked about the chip, but maybe we need also more tools, more real-time biomarkers or sensors to better describe the environment and the phenotypes. And we will need also more and more facilities to manage the data. So we need more IT infrastructure and pipelines to deal with this huge quantity of data that we have to face right now. And again, if we manage to make that, maybe it will be better to take, it will be more easy to take informed decision. So just, of course, we need always more knowledge on biological mechanism. Maybe we need more tools to better manage the data, so standardized data, I don't know, but we need to find a way to build up this new kind of reference population. But just everything is also possible with a tight collaboration between research and industry. And in fact, by attending these 2 days with you, I'm thinking that maybe we are not always aware of all the research, all the work that is done, but that is needed to go further with our objective at the industry level. And I just want to take a comparison. So when, for example, we walk into the forest, we tend to look at, we tend to look ahead, we tend to look at the leaves, but we forgot that we are walking on the soil with a very expensive root system. And for me, what you are doing, this is this root system that makes then everything more solid and that helps us to project in the future. So we need to continue and to make this close connection in between research and industry for very relevant services for the farmers in the future. And thank you.
Thank you, Clotilde. We are already behind the schedule, but maybe there is room for one question. We have time. Okay. So, any question in the room? Renzo?
Hi, thanks for the talk. What's the difference between a normal SNP chip and this epigenomic chip? What are you particularly interested in, or what did you put into the chip? Can you say something about that? Thank you.
So the way the two chips, so they are very, very similar in the sense that it will be exactly the same technology. And so far we are doing this both chip with Illumina, so same technology. But the fact is that on one side we have the SNP for genotyping, so with the full alleles. And on the other side we are working on DNA methylation. So we will measure, thanks to this chip, the level of methylation depending on the different sites.
And to obtain to obtain a polymorphism which can be tested with the chip, DNA is transformed with a bisulfite reaction. So the cytosines which are not methylated are transformed into thymine, and those which are methylated stay as they are. And so you generate a polymorphism which can be tested on a chip. Any other question, Graham?
So, the University of Alberta, you pointed at an economic study showing the value of genotyping heifers. Is there, or are there plans to do a study to look at the economic impact of epigenomics, or epigenetics, sorry?
We would love to, but no, so far there is a first economic study on genetics, on genomics, and right now in France we are doing a kind of big study to really assess the impact of genomics on the 15 past years. I think it's already a kind of job. And then for epigenetics, of course, so far we need more clue, but we first need more scientific answer before to think about the economical aspect.
Christa Kühn, FLI. I have a question regarding how do you organize the genotyping, because the DNA of an animal is fixed once the embryo is there. However, the epigenome can vary during the lifetime of the animal. So do you have a constant age for the animal to be epigenotyped, or do you try to have repetitive genotypings across the lifespan of an animal? So what is your strategy with this, how to deal with this potential dynamic?
So this is a big question because it's not only the question of the age, it's also the question of the tissues that will be sampled. And based on Rumigen, so we hope that we can have a little bit more information about that. But the strategy that we are imagining so far is, okay, we sample the animal from birth so that we get the first GBVs from classical genotyping. And then maybe we could come at regular stage to make more samples. Or, for example, if there is a sudden heat stress that we know, so maybe we can sample after that. But before to do that, because it would be very, very costly if we come back to farm and again, not only sampling, but making the analysis, I think economically it would not be very, very interesting. So we have to find, based on Rumigen project and maybe further project, we need to really determine what is a good tissue, the good time, the good the good time to produce the analysis, and let's see if we can make a combination in between the classical genotyping and epigenotyping. The best would be to have everything on the same tool, but this is not yet done.
May I something? On this first, this chip has been optimized for blood and partly semen, but blood was the main target. Then blood can vary in terms of the proportions of the different white cells. So there are specific marks which allow to a deconvolution of the blood formula, the proportion of the different white cells, which is very important to interpret the results. And then all the probes have been optimized in order to be variable between individuals and not between tissues or between the main characteristic is that there is a variability between individuals, and that's probably the major difference between this chip and those already existing, which are more specific to which gives information between tissues or between age, for instance. Of course, the molecular clock is also included, so we can trace back to the age of the cells also. And we designed this chip essentially to have a high throughput system. And the first one in Rumigen is a large design with 5,000 cows, which are already sampled, and there will be epigenotyped in the next months. And there are a number of smaller designs, especially to study the evolution with age or with some physiological or pathological situation.
Hello, James Clotilde, Iowa State University. It was an interesting talk. My question for you, you talked about potentially using the epigenome to characterize the environment. Are you also within the Rumigen project or otherwise looking at ways maybe to define contemporary groups like a heat stress contemporary group or a disease contemporary group that could be used to adjust the breeding values in some way to make them more representative of the genetic effects? Thank you.
Thank you for the question. So I don't feel very comfortable to answer the question, but the Rumigen project is very broad and wide, and I think so. There are also work packages that are focused on heat stress, for example. So, and in that case, these are just different groups that are widespread across the different countries. But then, and we will also run some analysis to compare what has been done across countries, what we could just see from classical genomic selection, and now with epigenetics information. But I'm not sure that it has been done, like you mentioned, with this contemporary group in comparison.
Maybe that's not the right way technically to describe it, but I was kind of thinking you could have an overall class effect in a model or something that would account for these shared environmental effects that could be tracked by epigenetics.
Mm. Our first goal within Rumigen, this will be done in my team, so I know that quite well. We will consider the genomic evaluation model with SNPs and add this component to see how it improves the prediction. If there is some improvement, it means that there is clearly a way to go in order to develop something in routine. It does not provide any additional gain. We will see what to do. But a lot of uncertainty at this stage.
Yeah, sorry, maybe just one other comment. So at least in our populations, we often have missing phenotypes. So I was thinking of it a way you could capture missing phenotype,
sure.
right, also.
Krista again, maybe a follow-up question. Do you think that this is a shift in the focus? Because at the moment, with the breeding values, we are looking for the potential of an individual to transfer its genetic merit to the next generation, whereas this now could offer the opportunity to better predict the phenotype, which is a difference. Yeah. If you look a little bit into the future, where do you think is the larger perspective? On the one hand, improving the prediction of the genetic merit, or on the phenotype? Because both can have also different aims then for the farmer.
There is a long-term perspective with genetics, of course, so because we are preparing the future, and we know that it's a long-term effort also to do that, and based on genetics, we have also to manage the variability, so I strongly believe that genomics helps also to better know about the variability and help managing it. I think we already also saw some example yesterday about that. But then the question that is raised by epigenetics and the fact that we could maybe better predict phenotypes, I think it's very, very interesting for the farmers right now, because the main focus of farmers is to manage the farm today and to have the clue to adapt their behavior to this changing environment. And when I say changing environment, it could be okay, the temperature, the climate, and so on, but also the economy or just the wish of the society. So, at ELIANCE, we have really the chance to have companies that are focused on breeding, companies that are focused on supporting the farmer day to day. And I think epigenetics is a way to complete our breeding tools today and to provide this information that is very focused on the, not on the short term, but on the daily life of a farm. So we hope that it will explain enough of this variation across the phenotypes to help us to transform this into an advice, a concrete advice to farmers.
And the large design we are going to implement is also a way to study the transmission of the epigenetic marks. So, of course, so are they inherited, and are they inherited due to the SNP, due to the genetics, or independently of the genetics? What is the relative part of the genetic determinism, the genetic and the environmental part in what is the relative part of the genetics and of the environment in the transmission of the methylation marks? And if there is some transmission from one generation to the next due to only environment, it means that we have additional information. Any question? Line? No? Okay.
Thank you.
Thank you, Clotilde.